Hello. In last lecture, we have discussed HTTP cookies, and previous to that, we have discussed caches. In this lecture, we will discuss HTTPS and authentication. Basically, when you enter a website, it asks you username, password, and typically what happens, give you some idea what really happens there. So we'll discuss basic authentication that we see, and then does HTTPS makes it secure, what HTTPS gives you, what the drawbacks, what we need to be careful when accessing HTTPS, and the general notion is everything on HTTPS is fully secure, and we'll see there may be some caches which you need to be aware of that. So first let's start looking at authentication. So if you look at to access some web page like this, you probably see a screen that asks you enter username, enter the password, and you proceed. And most of the convention is when you enter username and password. So basically, see you enter, let's say, username test, and when you enter password as something, so you don't see as a password. What you see is star 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 star, and we should note that even though display star star, it is only hiding from the display, but actual transmission is not transmitted encrypted. Most of the people or students believe that this is encrypted and transmitted and this is secure, which is not true. It actually the username passwords get encoded using base64 encoding, and we'll discuss how the encoding happens. But just to give you a demo, let's access the web page. We'll go to the site, open, let's say Firefox. I go to the site http colon perusgi.com worksource/web art HTML, and you see you are basically getting a web page which asks you username, let's say test. When you enter, let's say anything, it displays you this in the encoded, sorry, the star displayed is only hides the display, but actual password as it is, and if C even transmitted, it gets HTTPS encoded. So let's look at how does that really work. Typical encoding, base64 encoding involves 64 letters. If you know, when you look at hex encoding, there are 16 letters, 0 to 9, and then 6 letters A, B, C, D, E, F. If you look at binary encoding, just 2 letters, 0 and 1. Similarly, that means base64 encoding, there will be 64 letters, and these letters are such that they are all printable ASCII character. The letters are given. First, you have all these, what is called capital alphabets A to Z. That makes it, so let's say capital A to Z, 26 letters. Then you have a 26 small coast letters. Then you have a 10 digits. This makes it 26 plus 26. Sorry. So 26 of capital, 26 of small, 10 numeric digits, and 2 character plus and minus. So 26 of A to Z. This is 26. Small is 26. Numeric digits is 10, and plus and gives you 2. Together this becomes 26 plus 26, 52 plus 10, 62 plus 2 is equal to 64. And that's why these 64 characters are used in base64 encoding. And there's a one more letter used which is called filler. In case some encoding is not complete, they're always done in a blocks of 4 letter characters. So anytime you less than that, filler is used and will show the demonstration in a while. Now, how does a given input is converted into these 64 letters? So look, when you have 64-bit encoding, how many 64 base 64 encoding, how many bits we need? If you know that for binary encoding, which is two letters, we just need 1 bit. For hex encoding, which is 16 characters, we need 4 bits because 2 raised to power 4 is equal to 16. This way, if I'm doing base 64 encoding, that means for base 64 encoding, how many bits I need? I need 6 bits because 2 raised to power 6 is 64. Hence, I would need 6 bits of encoding. And we'll look at how the encoding happens. So let's look at how the actual encoding happens. Let's consider a case that somebody enters letter as CSE. CSE will look at in ASCII. C corresponds to hex 63, S corresponds to hex 73, and E corresponds to hex 65. So whole thing is, if we write in binary, this becomes 6 3 6 3, then you have a 7 3, then you have a 6 and 5. Now to get how do we take the binary representation and how do we convert into our 64 letters? So if you look at our 64 letters are A to Z and give indexing there, you first take the basically first 6 bits. First 6 bits are this, which basically gives you 0 1 1 0 0. Next 6 bits are this. If you look at, these are the next 6 bits. Then these next 6 bits are this, and then your next 6 bits are this. So if you take in 3 characters, each ASCII is 8 bits becomes 24. It perfectly gets into group of the 24 and 24 bits 6 bits at a time. It gives us 4 letters for each of these. But in case the is only not 3, then you take 6 bits, something will be left over, and then you pad up with zeros, and that's why we get a filling character. Now for this each of these letters, let's look at how the encoding is. So this letter 6 bits in value wise corresponds to 24, and if you look at the alphabet order, A corresponds to value 0, B corresponds to value 1, that way Z corresponds to value 25, and that means 24 which corresponds to letter Y. Same way, the next letter, which is 11011, value corresponds to 55, and we'll look at this corresponds to letter 3. Next is 001, 101, this is value 13, and value 13 will correspond to letter 19. So let's look at our values are 24, 55, 13, and last value is, if you look at 37, which is a small letter n. The values are 24, 55, 13, and 37. So if you look at values are 24, if you look at index 24, this is Y. Next value was, if you look at, we look at our next value was 55. This gives me value 3. Next letter was the, let's look at what the next letter was. 13 and then 37. So next letter was 37. 37 gives you small n, and next letter was the, after 37 we got, sorry, I forgot again, let me go back. Our last letter was 37. So 13 is n and 37 is L. So 13 is n and 37 is L. So this is the first one, this is the second one, this is third one, and this is 37th is fourth one. So what will get CSE will be encoded would be capital Y, then we have a 3, then capital N, and then small case L. This is how the CSE would be encoded into Base64 encoding. So how does the username password get encoded? Because user enters username and password. How does the encoding? So whole thing becomes a string separated by a colon. So when user enters username CSE and enters password, let's say NET, strictly constructed as CSE colon NET. And when you represent this CSE colon NET in ASCII in the hex coding, the value would be 0x for C63, For S would be 73, for E would be 65, for colon is 3A, then for N is 6E, then for E again it is 65, and then T it is 74. Now you represent in binary, take 6 bits at a time, pick up the respective letters in the table as you saw for 64 characters. So look at the previous table, we look at, so look at the previous table here, we have 0 to 63, and this is the fuller character. So total we have, starting from 0 till 63, we have all the 64 values. This is how you encode, and the fuller will come to full out to fuller use that. So let's look at which is CSE is correspondent this, convert into binary. So we've already seen the CSE corresponds to capital Y, 3 and L. Now look at colon and it make 3. So this group of 3 colon and E, or which is basically 3A, 6E, 65, would give us the next 4 letters 0M, 5L, and then we are left with letter T, which is, this is letter T. T is encoded 74. So if we look at 74, the value corresponds to 0111010. If we take 6 at a time, this value is 16 plus 8, 24 plus 5, 29. So 29 corresponds to a small case d, because well, index 26 would be small a, 27 would be b, 28 would be c, and 29 would be d. Now we are left with 0. Now, but how do we need to make a blocks of 4? So we paired up with all 0. This becomes 6 groups, then another 6 groups, and then another 6 groups. So look at, if this 0, 0 encoding is the first encoding value 0, which corresponds to A, and 6 the other fuller letters, this gets the value equal sign here. And this is how the filling happens. So look at, this encoding typically happens, and that's how encoding works. So please understand, anytime you enter username password, if you are using HTTP that actually transmitted as Base64 encoded, and knowing how the encoding works, you can actually decode it back and understand. So it is not secure. Just because it displays star does not mean it is secure transmission. For secure web access, what taught is HTTPS. We normally use HTTPS. And just before that, how do you configure a website with Base64 encoding authorization? So look at the header, whichever directory you want to access, that it is should be HTTP, should be authentication base. Define that directory like this, and then define authentication basic means we are doing Base64 encoding. You give different indications and where the password file is. So just to give you access, I'll access my web server. Let's say I log into SSH. So if you look at VI, etc, Apache, I would say sites enabled. For better readability, let me just go there. So look, so we are basically saying directory where www.html private, authenticate basic for CSE department, and all password information should be kept in this file. So how do we generate username password? We can basically say sudo ht password. If you do -c option as given into our this thing, it will create a new file. If you don't give a -c option, so if I give a -c option, it will create a new file. If you don't create, it will basically add the, so let's say ht password, we say etc Apache, file name is, let's say, password file, and username, let's say RPR. It will ask me password for sudo account. This now it's asking password for a new password for this account. RPR, let's say RP Rustic is my password. Sorry, it gives you error. Let me run it again. RPRUSTAGI. It added, and if you look, entries made at RPR, and this basically means this is the un encrypted value cap. I'm going to start on something, and this is how things are done. So we create and restart, and this is how to. So let's move to HTTPS-based authentication. It's a common understanding and belief, which is mostly true, that HTTPS gives full security. So what does HTTPS gives? It basically gives authentication, it gives confidentiality and data integrity. So let's look at what kind of confidentiality and data integrity is. So authentication actually means it is the web server is not authenticating a user, it is actually the browser which is authenticating the web server. Typical authentication would mean client authentication, but that is done by the application. So but server does authentication, you give username, password through biometric or whatever phase. But how does browser knows that the website I'm accessing is proper? It's something like when you go to an ATM to withdraw cash, you enter your debit card or bank card, ATM card, and ask you OTP or password, you enter it. So the ATM machine or bank is authenticating you based on your OTP. But how do you know this ATM is genuine? Maybe somebody put a fake ATM and capture your entry information. And in fact, this, if you're unknown place, you have to be realistic that this could happen. Though there's no such cases in India, but it doesn't mean it cannot happen. So authentication, HTTPS, HTTPS authentication is primarily a browser authenticating a web server. HTTPS gives confidentiality. That means any data that is transmitted between browser and the server, other than the browser and the web server, nobody in the middle can actually read it, access it. It also provides data integrity. That means once data is transmitted, nobody will be able to tamper with it. If data gets tampered because it goes to different routers, then server or the browser would know and data would get invalidated. So why this is done? Because typical users are not tech savvy. So authentication of web server made sure, otherwise there will be a lot of fake sites and it may be user may be trapped to provide that information. So confidentiality primarily means nobody in the middle should be able to look at the data. So when a transmitter from a browser access Google or Flipkart or Amazon, number of routers, number of devices, whole data gets encrypted, and so there are number of routers people can capture my data, but all that they see is some binary dump, but they cannot decode and understand or decrypt data what is happening. That gives me confidentiality. Similarly, it gives integrity because if data is encrypted, if somebody has to tamper with something else and tamper the data, integrity is violated, and the other and recipient, whether the browser or the web server would know, and they would again discard the data. And this is how the security is given. So let's look at what typical authentication is. How does browser know that the web server is authenticated or not? This typically happens. A web server provides a website certificate and browser verifies that certificate is valid or invalid. It's something like you have a driving license, the driving license is issued by transport authority, and driving license contains your name and photograph. It contains validity period. It contains who issued the driving license, which is typically transport authority. For example, let's say you belong to university, and university vice chancellor or authority issues a driving license to you. It will have a validity period, it will have your right name, but issuing authority would be university. So if you come on the road, which is owned by the municipality or corporation, police would not recognize it. Though even within the university, your driving license issued by university vice chancellor could be valid, but that's not valid outside the university. So the browser looks at who issued the website certificate. Anybody can issue certificate, but browser must know the recognized authority who issued certificate, and only when it matches, then it accepts certificate and goes. If any of these three things, that issuing authority or validity period or the website name does not match what is contained in the certificate, it gives you a warning saying you are entering a risky zone and better not to go there. Basically, like a warning. Just to give an example, you let's say find out the Google's IP address, and we access the same IP address using HTTPS. So let's say this address is Google's IP address, and we access using HTTPS because browser has user has entered this name as the IP address, but Google certificate says google.com. Browser sees that certificate is google.com. Certificate says google.com, but what user entered is this. There is a mismatch, so browser displays a warning and says something is wrong. Let's look at a quick demo here. Let's go to our scenario. Let's say we ping google.com. IP address is this 172.163. Let's say then we open, let's say Firefox, go to Firefox, let's cancel it, enter this and say https ::. You see, you get an error, potential security risk. Why? Because what you entered username is this, is the site name. What certificate said is google.com, and there happens to be mismatch. And because this match, so look at the certificate, it basically is trying to see the certificate is mismatch, and that's the reason it's certificate invalid, and say don't access there. But if you proceed, accept, discontinue, then it goes and you get Google Page. Similarly, if you have a certificate which is expired, now so let's look at what certificate indicated by sign. Look at the certificate details, more information. It basically says expired so on 25th, so is valid. Certificate website is www.google.com, issued by Google, view certificate. So subject name this California, issuer is Google Trust Services, which are the browser trust. Certificate site name is this, validity period is CN is Feb 2020, and that's how it basically browser accepts that it is a valid certificate. And they were issued on so and so time. So let's go back. So you can look at if anything mismatches, it will not work. Other example could be you can make some entry into your website. Sorry. And do that. Now certificates are typically three kinds. One is called domain validation. So how to get a certificate? It depends upon how much money you're willing to pay. The different authorities like GoDaddy.com, you can go to get a website certificate. But you can go to VeriSign and this thing Thate or different places. A GeoTrust. The charges vary depending on kind of certificate you want. A basic certificate that only validates the domain verification saying the website name exists and there's the IP address for the website certificate issued. So that will cost you maybe some $200 or 1,000 rupees depending on the certificate issuer. Other is you want to get a little more detail. It says organization validation, that not only the site name exists but particular organization exists. But you want to detail more that actual organization does a business and proper address allocation or something. This is called extended verification, and that typically you see in a green sign, something like you see geotrust.com digital certificate with green sign says, so this certificate costs you a lot more money. So it depends what kind of confidence you want, you will get respectively that kind of certificate. Now, just because everything is HTTPS based does not mean everything is secured, and typically browser indicates the kind of, with the lock icon, what kind of web page access it is. If everything is completely secure, every content in the website is accessed using HTTPS, that means it's fully safe, and you'll see a sign either if you old browser you'll see a green lock icon, but today you'll probably see a simple gray lock icon. If you see that kind of sign, that means it is fully secure, nobody can tamper with it. But if there is a mixed content, and mixed content happens to be some passive content like images, which are accessed using HTTP, not HTTPS, then you'll see a sign which is great with a warning. This is telling you, look, the content is we are accessing with HTTPS, but this website has some content which is passive, which is not accessed using HTTPS. So some embedded content is being accessed using HTTP, and this could be a warning because it can be misused. But in case there are active content like some JavaScript, which are being accessed using HTTP, not HTTPS, then there's a warning sign, and you'll basically see when you see this kind of gray sign crossed by the red bar, this means this you are entering a dangerous zone, and that means some content is not HTTP. So even their main URL is HTTPS, but your inside content which is JavaScript, not HTTPS, and that could play havoc, capture things. So anytime you see these two signs, the gray bar or a red bar, red cross, it's strongly recommended that you don't access those web pages. Just to give an example, we'll open a Firefox and enter this content. Let's say Firefox. Let me close this, and so let's say I just enter this. I say https colon rprustigi.com workshops web. Let's say pure.html. That means this web page there is no embedded content which is not HTTPS. So if you look at, you get a gray sign, and if you do view web page source, it says there are two embedded objects. Both of them are accessed using source with no HTTPS protocol specified. That means by default, take the parent one, which happens to be HTTPS, and this is secure. If instead I were to access a content, let's say mixed, now you see a warning sign come up. It says part of these pages are not secure, such as images. And why? There are two images. If you look at view page source, you see it here. One page is accessed using HTTP and not HTTPS. The image one is accessed using HTTPS, protocol not specified, so it takes from the parent, which is the HTTPS, but second image says HTTP, and because mixed content, some content is HTTP, you get a warning indicating it. But if I'm using, let's say, some web page which have active JavaScript, example is active.html, you see that it says disabled, let's say content is secured, it has some active content which Firefox has blocked, but in case of Firefox is not blocking or configure not to block it, let's say disable protection for now, and you see a sign, basically that means content is not blocked. Now this has active content. If you do view page source, you will see view page source. We are accessing a JavaScript which is HTTP, and that means this access is not HTTPS based. This could be tampered with, and let's see what happens in this case. Since this content is not blocked, if I click, JavaScript gets invoked and hello works in. But if I same page, when I do a block access, let's say block the content, enable protection, access happens, and once the same post comes in, sorry, it's not coming up, let's say, yeah, it has come up. Now even the same button, you click, nothing happens because the respective invocation active script is blocked. So please make sure you should access a website only when you see the padlock icon, which is either gray or green one. That only means fully secure communication, otherwise it is not. So with that, we come to the end. As before, to make sure you understand and learn how HTTPS authentication works, few exercises. So first exercise is on your local Apache server, which you have been saying, create a web page or create files like st.htxs, define content in the server configuration saying this has to be authenticated, and then create the content with CSE or password ECE, and then access the web page. It should basically throw a browser like we have shown in the video lecture, and then verify that what you're passing is base64 encoded. So if you are using username is ECE and password is ECE, encode yourself using base64 encoding and verify it using the WATSR capture, what happens, or you can actually even verify with their website that tells you base64 encoding, what that would be, and you can content. Let's look at our encoding. We can probably go to Firefox. Let's look at, I can search for it, let's say Base64 encoding. Let's see if I get a web page. So let's add, remember we had a type, we did CSE colon net, and if you decode, you get the, sorry, not decode, it should be encode. We wanted to do encode, it should be encode rather than decode, we made a mistake. Okay, let's do CSE net colon encode. When I encode this, use the encoded value what we see in the earlier slides, the value would be, we'll just get that. It was Y3N small l. You see Y3 capital N small l, OM5 small l, DA filler. So you can enter. So before you actually verify it, do base64 encoding what we studied, verify whether it is encoding correct, that helps you. Next exercise is to look at how HTTPS works. Take your favorite site, let's say amazon.in or google.com, ping to these websites, find the IP addresses like what we did, access using HTTPS colon that IP address, let's say 100.200.1.2 whatever, and then you should see a warning. Doesn't matter whether you use Firefox or Chrome or Explorer or Safari, you'll always get a warning page to know, look at the certificate that tells you mismatch. Thirdly, you can actually go one step further and you can create an entry into your etc host file of the system. It's for local domain resolutions. So IP address and given name. Let's say find the IP address of Google, put that name, and then in the browser, enter HTTPS colon this site name and see what you really get. With this exercise, you'll probably understand how HTTPS works. So it's strongly recommended to work with the exercises that helps you. So what we had done basically now, we had more or less covered basics of HTTP protocol. We started with headers, then we look into more details, languages specific, how the uncompression happens, how the content type works. Then we look at the caching, we look at the cookies, and now finally look at authorization and authentication. So now next next lecture would be defining some project which you can work with to explain, understand better experience, and then we move to other high-level application protocols such as DNS, socket programming, and so on. So thank you.